there were something like 270 billion different design options. And so what genetic algorithms allows you to do is it allows you to take a small set of randomly selected options. Let's just pick 50. Let's run them through and let's evaluate those 50. And we'll take the best performing 25, right? The best half of that. And we'll say, what are the inputs that yielded those best performing 25? And you can start to mix and match those specific input values to create new outputs. When we talk about genetic algorithms, we are actually thinking about the genetics of a design that looks like it's performing well and say, let's mix and match with the genetics of another design that's performing really well and get a third one we haven't looked at yet. And all of a sudden, you have a whole bunch of different options. So instead of just one way to get to net zero, for the NRDC, we studied, I think, 2,000 or 3,000 different options, of which 80% of them were net zero.
Before we go into the podcast, if you could just go and rate this show on whichever platform you're listening to it, it makes a huge difference to the podcast, the amazing conversations we get to have, and the incredible guests we're able to get on the podcast. So it's probably not something you would think about, but if you could just go rate the show, follow it, or share an episode, it does make a huge difference to the show. Thank you so much. In a world increasingly facing the challenges of climate change, with the Building Green podcast, we will dive deep into the intersection of architecture, design, urbanism, and environmental responsibility. I'm Ladina Schipf, your host. I've been an architect and building site manager for the past 10 years. During my studies at ETH in Switzerland, as well as in my working environment, I've had many touchpoints with sustainability, like many of you, I guess. I've also learned to question what I've been told, which is why I decided to go deeper into the topic and uncover what sustainability actually means. My mission is to highlight the transformative power of sustainable architecture, not just as a practice, but as a catalyst for broader societal change. Subscribe for more of our content and enjoy the show. Zak Kostura leads a digital consulting team at Arup, a global multidisciplinary design firm known for finding solutions for complex challenges in the built environment. Zak and his team develop and use tools and technologies like AI and genetic algorithms to make buildings smarter, more sustainable, and more efficient. In this conversation, we explore how Zak's team uses genetic algorithms to explore thousands of design possibilities, helping projects like the NRDC's New York headquarters achieve net zero, and also how he's worked on transformative initiatives like AI-powered systems that optimize transportation networks, reducing the need for expansion. Let's dive in. Zak, thank you so much for joining me on Building Green. Before we go into all the technical details, can you share a bit about your journey? How did you start as a building designer and end up leading a digital consultation team at Arup?
Yeah, sure. It's a great question, Ladina. So I've been a practicing professional for about 21 years now. And when I initially left school, I was a structural engineer, and I got hired by Arup to work on a range of different structural types. I think one of the things that's really nice about being a designer here is you get the opportunity to be exposed to a lot of different typologies. So I've had the opportunity to design train stations and airports and commercial high-rise buildings and bridges and all kinds of things. And it's been a wonderful experience. In the course of doing most of those projects, I had the opportunity to leverage digital workflows. So starting in the early 2000s with BIM, and then moving into parametric design, computational design, generative design, and now AI. The last project that I did as a structural engineer was a very large airport roof for a project with Foster and Partners and Fernando Romero. And it was so big, and the project schedule was so ambitious that we actually had to design software to design the roof. And so we built this sort of web application that lived in the cloud and used a whole bunch of processing power in order to study options and everything. And when that project finished, there was just sort of like an internal thought, like, why don't we see if we can scale this up and do this more broadly across projects? And so I sort of took on the role as leader of a team of software developers and data scientists and geospatial analysts. And we've sort of broadened our remit. We work across all of the different markets that Arup works in to try to figure out how we can use software and data and technology to transform what we do. And so I've been doing that for about 6 years now. And interestingly enough, there's been relatively little structural engineering involved in that. I think because the opportunities elsewhere have just been so broad in being able to use these new capabilities to do things better, higher quality, faster, and that's sort of taken me to where I am today.
That's so cool. And for those who may not be familiar with Arup, can you tell me a bit more about the company and its mission?
Yes, absolutely. So we are we're a global multidisciplinary design firm. We work across every facet of the built environment, and we have experts in house that are knowledgeable about just about every aspect of the built environment, from structural design to acoustics to lighting to rail and highways to security to blast to fire to theater. We do it all. And so when there are complex projects, we bring the consultants, we bring the designers. We oftentimes support architects in order to do the work. We're in 73 countries. We have 19,000 people, so it's a very large organization. But that size gives us the ability to do some pretty big, impactful things.
That's really cool. And what does a typical day look like for you as someone leading a digital consulting team?
Well, Ladina, I think that the time I spent as an engineer having to learn how to design a completely new type of building, it solidifies a mentality that I think a lot of my colleagues have too, where you have the ability to sort of go into a new problem that you don't know how to solve and think through using first principles or just simply talking to people who do know. You figure out how to solve new things that you've never done before. And so with my team as a set of digital consultants, oftentimes I will go into the areas where our team hasn't really worked before, new types of projects, new types of technologies, and I'll help set the team up. And if needed, secure the new capabilities, the new skills, whether that's training or hiring. We get the team up and running in that new area, and then I move off to another area to help the team grow in capability somewhere else. So every day is sort of coming in and being linked to somebody brand new in the company that I've never met before, talking about a new type of problem I've never heard of before, and then using a lot of Chat GPT and Google search.
So you've worked on fascinating projects like the airport roof and others using generic algorithms to improve the building design and reduce embodied carbon. Can you explain in very simple terms how these algorithms work?
Yeah, sure. So, and it's interesting because I know that, the overarching topic of the podcast is around sustainability. And I think that this is an area, sustainability is sort of where I think the most exciting, use cases are for us in this space. So, anybody who has done design knows that there's a lot of possible outcomes, right? You go in to design a building or anything, and there's a lot of different ways that it could turn out, right? Depending on the decisions you make around the design and what kind of glass you pick for your windows, what kind of finishes, what kind of layout, right? All of these things have an impact on what comes out. And in terms of sustainability, how much energy it needs, right? And so within a particular building, you could think that if we pick more insulation or a different kind of glazing, that maybe it's better insulated, it doesn't bleed so much heat, and so the building takes less energy to heat, that kind of thing, right? And about 6 or 7 years ago, we partnered with Studio Gang, Jeannie Gang Studio in Chicago, to design a new flagship headquarters office for the Natural Resources Defense Council, the NRDC, here in New York. So it was an existing building. They wanted to fit out, but they wanted it to be net zero, which means, of course, that the building is supposed to produce as much energy as it consumes, and that could be either on-site energy generation or maybe off-site as well. And historically, that's something that clients have asked for. And the way that we've done it is we just use our intuition. We say, all right, well, if we pick this combination of stuff, we've run the numbers and it will get you to net zero. And oftentimes within the realm of a simple design, you'll get one or two of what we would call a pathway, right? The set of design decisions that get you to net zero. But we have new opportunities now with computational design. And a lot of, I think, the listeners to your podcast probably know about things like parametrics or computation. This idea that we don't just sort of statically draw a building, but we can create a digital workflow of those decisions, right? So we can use something, if people know things like Dynamo or Grasshopper, these are very common tools for doing this. But it's sort of like, instead of just drawing the output, you say, all right, well, I'm going to create this outfit, this office fit out. I'm going to, wire it with this kind of layout, and buttons and sliders, and you can change your decisions and you can rapidly see what comes out the other side. You can also do it in Excel, right? Where you've got a cell where you change the value and you can see the outcomes that happen, right? So you create some sort of digital representation of the design that you have the inputs and then you get the outputs, right? And that's something that we've been doing as designers now for 20 years, using different tools and software, just sort of like a parametric workflow. And what this sort of new approach involves is it involves us basically automating the process of changing the inputs and looking at the outputs and evaluating the outputs. So in terms of like the NRDC project, what we did was we created that design in that kind of digital workflow. So we could say, let's change the glass, or let's change the time that the lights are automatically turned off. Let's change the type of mechanical system. And as we did those, on the other side, we had a calculations, how much energy will it use? And so you could change these and see what you do that changes the outputs. Now, that's, again, something that people have been doing for a while. You test different inputs, you see different outputs. But the thing is that when we talk about sustainability, there are so many decisions that we make as designers that affect the performance of buildings that it's become impossible to study all of the different options that are out there. For NRDC, there were about 120 different things we could do between glazing and mechanical systems, stuff like that. If we looked at all the different values, the types of decisions we can make, all the different combinations that led to different outputs, there were something like 270 billion different design options that were there. So you can't sit there and study all those, nor should you. And so what genetic algorithms allows you to do is it allows you to take a small set of randomly selected options. Let's just pick 50. Let's run them through and let's evaluate those 50. And we'll take the best performing 25, right? The best half of that. And we'll say, what are the inputs that yielded those best performing 25? And you can start to mix and match those specific input values to create new outputs. The same way that evolutionary theory says you sort of mix the chromosomes of the best performing species and you get a new best performing species, right? So when we talk about genetic algorithms, we are actually thinking about the genetics of a design that looks like it's performing well and say, let's mix and match with the genetics of another design that's performing really well and get a third one we haven't looked at yet. And with data science, we can start to look, as we study those options, what kind of performance are we getting out of that population? And very quickly, we start to see that there's an upper limit to the performance. And data scientists can look at how that's all going and saying, well, after, 1,000, 2,000 options, I feel like I've got a really good handle on what the upper bound energy performance is. And all of a sudden, you have a whole bunch of different options. So instead of just one way to get to net zero, for the NRDC, we studied, I think, 2,000 or 3,000 different options, of which 80% of them were net zero. So now the client doesn't just have to take the consultant's one way to get to net zero. They can get to net zero and they can pick their preferred mechanical system. Or they can say, we want to get to net zero and we have this kind of budget. Or they could find out that the type of glazing that they assumed would get them to net zero, it's not available because of supply chain problem. They can pick another one and figure out how to get there with that, right? So there's a lot of different options in terms of flexibility that a client can have by using genetic algorithms to study many different ways of getting to net zero. Does that kind of make sense?
That makes a lot of sense, and it's amazing. Just yesterday, I talked with a furniture designer about how AI, on a very basic level, how it gives you back time. Now, imagine how many hours of work that would be if you would have to do
Yeah.
it.
Yeah. And Ladina, just on that point really quickly, we're consultants are paid, based on a certain number of assumed hours, right? And so if you think about the quality of a building or the built environment, right, it really comes to how well you can use your time. If you can use it more efficiently, you can get a better outcome, right? Absolutely.
Yeah, it's amazing. And how do you decide about the inputs? Do you have like a standard library of products which you pick from because the others are already like below sustainability goals, or how do you go about that?
Yeah. So in the case of these, what you want to do is you want to understand what's available. So there is quite a bit of expertise that's already there. And to give another example, Ladina, we use this with Whole Foods. As a owner of many different stores within their supermarket chains, they were looking to reduce the energy consumption, and we were able to use the genetic algorithms to see how they could target specific interventions to make their supermarkets more energy efficient. I think we were able to propose sort of a 50% reduction in overall energy use across the Whole Foods portfolio. And in that, the initial catalog, as you might imagine, are the types of equipment, the types of materials that Whole Foods uses, right? In terms of the way that they design their sort of branded buildings, the types of mechanical systems that their procurement teams can already procure. So you want to curate that catalog based on what are the parameters of what is practical, what is, approved by the client, what is sensible. But to your point also, you want to curate a catalog that has low embodied carbon, easy to procure from an energy and sustainability standpoint as well. So you're starting with a good foot forward.
You've touched a few points during the design phase. Can you walk me through the design process and talk about how algorithms come into play and which ones are the most important at each design stage?
So in terms of algorithms, you're just talking about sort of like a way of synthesizing inputs to outputs, right? A way that designers is sort of like replicating the designer's thinking in terms of the way a computer works, right?
Yeah.
So, I think that uh, it's difficult. I think it's difficult to pinpoint a specific way to answer that question. But I think that what is kind of under the surface there that I think is a really good observation is that we can make the mistake of thinking that we should turn every step of the design process into an algorithm, right? And a lot of the thinking and creativity and decision making that's done is really done best by humans. I think it was the founders of PayPal that really sort of started to create this philosophy in terms of software and design that the best process is a human in the loop process, where what you do is you automate or create algorithms for the plugging and chugging side of things. And what your algorithms should do is they should synthesize a set of outputs that then can be decided upon by a human, right? So in terms of like the Whole Foods example, which, or NRDC, when we're doing that initial genetic algorithm, that's sort of early stage, right? We all know that as designers, when you get in the concept stage of a project, it's very malleable. There are big decisions you can make in terms of massing and program and dimensions that by the time you get to like, DD or CD construction documents, right, you're really down to tweaking the fine details and you don't have those big. So in terms of the concept stage, I think that is a real opportunity to create algorithmically generated workflows that first off, speed that process up so that you can look at a bunch of different options. But I think what we've also seen, and I don't know if you've seen this too, Ladina, but because of the way that algorithms can take aspects such as biodiversity or embodied carbon or resiliency, there are considerations that design teams would kind of push off until DD or CD just because they didn't have the time or the bandwidth to study those across all of the different options that happen during the concept stage. But now, if you're able to create an algorithm that says, all right, where can I put beehives or allow bats to live or, allow, native species to be able to migrate across my property. All of these different things. Those are things that we never would have thought about in the concept stage, right? We would have just said, let's do the best with the final design. But now we can say, well, let's actually think about what's best there and let's weight that consideration against all the other considerations that I have and pick a concept, at the point in time when the project's malleable that does the best against those metrics as well. Have you kind of seen that? And have people kind of talked about how they're able to consider more upfront when you have big design decisions that you can make still?
Not really. No, we haven't really talked about all the possibilities we have with those tools. And it's a good point. It's funny, it goes back to what we talked about yesterday, again, on a very different level, that it saves you time where you actually need it. And I feel like often in the design process, you're overwhelmed with decisions. So you need to break it down and prioritize, and the beehives get forgotten or,
Yeah.
yeah.
Yeah. And I think, in terms of, in real world terms, right, what we see is a world now where, supply chain is a huge issue. Availability of labor is a huge issue. And of course, whether or not people actually want to put beehives on their buildings, everybody's building within jurisdictions that now have more stringent sustainability and energy performance criteria, right? So our job as designers at the very beginning of a project, maybe we even haven't won it yet, right? Maybe we're doing the competition concept out of pocket, right? And in those stages, we're really limited in the number of considerations we can really entertain. But what algorithms, AI, genetics, genetic algorithms, computational design, what these things allow us to do is to be more holistic, right? At those points in time when we have the big ideas, we've got the ability to execute on them. Because all of us designers have gotten to the point where we've gotten into construction documents and we're kicking ourselves because if we had thought about something earlier, we would have been able to make that change when the project was malleable to sort of allow the performance to be better, right? So the more we can think up front without overwhelming ourselves, I think the better we can get to in terms of an end product.
Definitely. And so how does it usually work? Do the architects come up with a few concept ideas and then you run them through the program, or does the program give you a certain amount of ideas and then the human decides which one is better at the concept design stage?
In best case terms, it's a mix, right? I think that what we've seen is that where people have started with some sort of algorithm that they're like, I'm just going to close my eyes and this is going to design the building, right? It never turns out that way. And honestly, it probably shouldn't. But what these things become more often than not are collaboration tools. Have you heard of Autodesk Forma, for example? Yeah, right. So I think that's a really interesting tool because there you have Autodesk sort of building a software solution that allows you to both sort of specify the building massing, the building design, but also perform analytics on it. And the way that I think Forma and there are other examples too, like Schema is one we've been looking at here recently. We even have an in-house one called Inform that's similar. But what they do is they perform some very quick high-level analytics. They show you what the wind comfort is at ground level. When it's windy, where is it going to be comfortable, where is it not, based on the position of trees and the building massing and stuff. And can you nudge things around to make the ground plane more comfortable, right? It's not something where the tool just gives you the design of optimal wind comfort. What it does is it shows you the implications of your design so that you can have a conversation with all of the project team members about how to resolve that issue. And so I think that in terms of the way that it interplays with us as a design process is very nuanced, and it is something that it kind of comes back to empower us to make decisions. And I think we have to be like, one of the things that we need to do in terms of our own mindset in this sort of digital age is to be much more aware of when we're doing analysis versus when we're making a decision. And sometimes we conflate those things, right? But, these tools will do the analysis for us. They'll visualize the outputs. And then we need to be ready to be able to make a decision at that point based on what the computers are telling us that then sets off another stage of analysis, right? That leads to another decision point. And all that can become pretty incoherent if you're not careful, right? And I think in the past, decision making has been kind of fluid and organic. And when we're going, sort of human in the loop interaction with computers, we need to be more deliberate, I think, with it.
If you're enjoying the show, I have a small favor to ask that would mean the world to me. By rating and sharing the podcast, you're helping us grow and spreading our mission of making sustainability really desirable and cool to a wider audience. Besides of that, imagine impressing your colleagues with the latest insights on sustainable architecture. So make sure you follow the podcast and become the most informed in the room. Thank you so much for your support. I'm a very strategic person, and I think often in architecture you have to take decisions without having like all these data, and so it feels like you cannot make kind of confident decisions, or depending on what we're talking about. So we've spoken about not just enhancing the design phase, but also the operations of buildings and infrastructure. Where are some of the biggest opportunities in operations?
That's a really great question, Ladina. And, to illustrate that, I might step out of buildings for a minute and look at some of the bigger, more complex systems that we've been able to work on. And in fact, one of them that we're working on right now for a state level Department of Transportation that's overseeing the roadways around a major U.S. metropolis, we are developing an AI-powered decision support system that essentially has a digital twin of the entire transportation network for a big part of the state. And it is constantly monitoring where vehicles are, where the buses are, the conditions of the roadways. And when there's an incident like a crash on a highway, what it's going to be doing is it's going to be evaluating and simulating a set of response plans. Direct drivers to get off on this particular exit, change the traffic light signal timing to put more green on the left turn arrow because there's a bunch more cars off the highway, encourage people to go to the nearest commuter lot or train station or something, right? All these different things. And it's going to be able to put that up in the operations center for all of the agents to then just implement. And the reason I think that this is a really interesting illustration is because this is an example of AI allowing operators of a complex system to operate it better, right? So the thesis that is ideally going to be proven through this project is you can get more travelers through the existing network if you operate it better using AI. The alternative approach is to just add more lanes, right? Have a big highways project where you take eminent domain over a bunch of buildings, you add more lanes, you widen the highways, all of that obviously capital intensive, environmentally damaging, right? So in this case here, instead of doing that additional construction project, you use AI to operate the system you have better. And I think we have the data points that are suggesting that yes, actually we can operate complex systems like this better. It means that the capacity of the networks increases simply through operations and AI and data, as opposed to actually physically making the systems bigger. And I think that the same thing can apply to our building stock, right? In the sense that when we have facilities that need to be maintained, we oftentimes have a scheduled maintenance or improvement approach that isn't informed by how things are actually operating. That it is just simply on average that filter needs to be swapped out every 2 years, so time to swap out that filter. And what these systems can do is they can provide a layer of procedure and process that's informed by the actual performance and the predicted performance, so that we are operating our existing building stock better. And I think what that means is the OpEx costs of buildings and the energy performance and sustainability will improve, but actually the degree to which we can stretch our existing building stock should be able to increase as well and offset the need to build more as well. And I think that is a major proposition around sustainability, is to better operate what we already have so we don't need to build more.
I love where the world is going right now with especially with the help of AI, to optimize what we have, optimize our workflows and our transportation flows and all that, instead of building more, building better, building newer. That's really cool. And about the project with the transportation and the water networks, what are some of the toughest challenges that you're facing there?
What we're talking about in a very idealistic way is changing the way the complex networks are operated. And when we talk, and it doesn't matter if we're talking about a building, we could be talking about a university campus, or we could be talking about a highway network, or we could be talking about a water system. These complicated systems have been operated by people for decades. And every organization or entity that's in charge of one of these has binders and binders of existing protocol and procedures on how to do things, and they've got a whole group of individuals that are trained up on the existing way of maintaining these. And it is no small amount of effort ever to get an entire organization to transition to a new way of operating, right? So in terms of this highways project that I just mentioned, it's not just one agency that manages this transportation network. It is state level DOTs, local DOTs, signaling teams, dynamic messaging teams, transit authorities, bus operators. And so when we talk about operating the network better, we're talking about taking all of these groups that have kind of operated independently and make them coordinated in their effort and their response. And to some degree, and I mean, it's a little bit sort of like flippant to say, but the bigger challenge is how to change the mindset and behavior and attitude of the people versus the technological challenge of implementing AI to do it. That is hard. But what is, in my view, really hard is changing people's behavior around how these systems are operated. And you see that with facilities management teams. You see this with, water systems management teams. In airports, everybody has established processes, and there are typically big consequences if people don't operate these things the right way, right? It makes the news. Airports are suddenly delayed, right? It's like big consequences. So transitioning from how we do things to how we could do things is more than just sort of like a thought exercise. It's a big deal. And we, I think, as a society have to get better at that kind of change management that actually comes with us implementing these digital processes.
Can we talk about responsibilities in going back to where our conversation started? So the human puts in some inputs, the algorithms analyze whatever we have and give us certain outputs that help us take a decision. But what if there is like something going wrong while the algorithm is analyzing data and the output is wrong? Who has the responsibility for that?
In the digital age, there is a lot of focus on responsibility and accountability. And I think to the very point that you've made is if we're not careful, we can create black boxes and we can become overly reliant on those black boxes. Now, I'll give you a quick sort of anecdote that when I'm on sort of speaker panels, I kind of point back to. But when I was a young engineer, I was sort of like 3 or 4 years into my career when I was sort of initially asked by my line manager to put together my first global building model. Right, so I'm a structural engineer. I've got this 38-story tower, and I'm supposed to design the structure in the computer and set it up so all the beams and columns are properly sized for all the wind loads and seismic loads and gravity loads and everything on it. And then when I'm done, take it to my line manager. And I spent about a week or two putting that model together. And then I told my line manager, I said, hey, I'm ready to show this to you. He's like, great, come on up. And so he puts it up on his screen, and I'm sitting next to him, and he spins it around, and he opens up this box where he just sort of like looks at, for structural engineers in your audience, the global loads and overturning moments. It's just some simple little report. And he looked at those numbers and he said, this is all wrong, Zach. Send it back, do it again, right? And I had made some big mistakes in the way I'd applied loads, the numbers I put in, all of that. And in this analogy, I was the black box, right? I was a young engineer who he wasn't monitoring my every process. He gave me a task. He wanted the output. But as the professional engineer of record, it was his responsibility to make sure that the output was correct, right? And he had the skills and the techniques to be able to at least start to suss out quickly and efficiently the validity of what I gave him. Right. And I say that because in the digital era, especially the AI era and the data era, we go right to, oh, it's a black box. I don't trust it. There's no way to trust it. And I say that's Boulder because for decades and decades, for centuries, since the beginning of sort of like collaborative work, we have been in a position where we've been able to find ways to validate black box situations to bring our own accountability to work that others have done. And in the case of computers, algorithms, AI, we have a different set of techniques in our toolbox, but it's essentially the same thing, right? And so on our team, we have data scientists, and actually right now we're talking about, on that DOT project, how there's just thousands of possible recommendations that the system might give to an operator for them to be able to implement. And it's not practical for the operator to go through and individually make sure that each type of recommendation is right. Just like Google Maps, right? Google can't check every possible route from every point A to every point B to say this thing is 100% right. We stand behind it. They use data science, right, to say here's a statistical subset of the outputs. I'm going to check them, and I'm going to continue doing this until I have confidence that the system and the algorithms and the process is working. So to your point, Ladina, I would say whoever would be responsible for that work product, even if that algorithm or AI module or tool or whatever was not there, that person's still in charge. And what they need to do is they need to have the right competence and skills and techniques to be able to stand behind what this tool that's being used under their supervision is putting out.
It's still kind of your intern or your tool, and it's not a person that works itself. And how long do you think, or do you think we're ever going to get to that point where AI starts taking decisions, or it starts, you said before, like, it's not that it's going to give you the perfect sustainable project, but it's going to analyze what you put in. Do you think we're going to get to a point where the output is a perfect, I don't know, not sustainable building, because it depends on what parameters you're looking at, but the perfect wind or ventilation system?
I think so, Ladina. I mean, to some degree, it's already doing that. In the decision support system that I just mentioned, right? It does decide what the best response plan is. The humans set up the scoring rubric that the system uses, but then the system decides the best response to a car crash or something like that. I think that under analytical circumstances where it's essentially selecting something based on a set of criteria that's easy to define, that will happen. But I think that, there was a really interesting article about 2 months ago in the New York Times by this journalist, Kashmir Hill, where she actually used ChatGPT for a week to make all of the decisions in her life: what to cook, what to buy, what haircut to get, what color to paint her office. And her conclusion on the other side of it is that it is possible to use AI to make your decisions, but because of the way that AI is trained, it is going to push you towards the most mediocre decisions, right? She'll go to Old Navy and she'll buy the most basic scoop neck olive colored shirt because that is what the AI was trained statistically to pick, right? So if you're looking for decisions that are unique, delightful, out of the ordinary, AI is not really well placed to do that. And by definition of the way AI is trained and configured now, it shouldn't. What it should do is it should say to you, people typically do this, or this is the average right answer. And in situations where that is what you're going for, the decision couldn't be made by AI. But you can imagine, you think about all of the different aspects of the built environment that we're delighted by, that was a creative edge case out of the ordinary decision by an exceptional or eccentric person, right? That's what defines the streetscapes of San Francisco and New York and all around the world, right? We want to make sure that that's there. And I think that that is intrinsic to who we are. And I do think that it's in our best interest. And it is, in fact, I think something that we all hope will happen, that we will continue to build these processes that make the right decisions made by people who can do that, and then the appropriate decisions by AI.
I mean, it is trained based on things that have worked well or worked badly in the past, and not to take innovative decisions for the future.
Yeah.
Yeah. So in your opinion, you've talked about there's many ways or paths to net zero for like a homeowner or an architect working on smaller projects. What are kind of the requirements you'd rely on most to get to net zero?
Where I typically start in thinking about a project is the relative weight between embodied carbon and operational carbon, right? What's the environmental impact of building it, and what's the environmental impact of operating it? And being clear on those two things, I think, is really important. And when you're talking about small projects, typically the operational impact is far and away greater than the embodied impact of it, right? If we're talking about California high-speed rail or something like that, the rubric is switched. So big projects, the embodied carbon is a way bigger deal, right? So I think that is one thing that I typically start with, is understanding the dynamic between the two. And then when we talk about operational carbon, I think where I go, and this is sort of as a digital practitioner, because so much of what I do is decision support on the part of people, I think about the aspects of operational carbon that can be mitigated by ongoing decision making, right? How often is that facilities manager switching out that filter, right? Or at what point in time is that facilities manager turning off the lights or turning the heat down? And say, is there an intelligent way to automatically do that? Right? I think that's the key aspect that's there. The other side, of course, is the design decisions that you make that affect operational carbon, right? If you pick a more efficient mechanical system, nobody has to do anything different. It's just going to operate more efficiently there. So I think, I tend to think in taxonomies, like I think a lot of us do that are technically minded in the architecture and engineering space. And so the taxonomy of those sort of buckets of decisions and actions that affect the different subsets of your embodied carbon, operational energy, that kind of thing, I think is important. And at the end of the day, what typically winds up being the biggest thing is the design decisions you make right now that affect operational carbon. And then I think the second thing, in my view, is the ongoing decisions made by the building maintenance and operations team that affects the operational. And the third one is the embodied carbon on small projects. So, I don't think I can get more specific, because we're staying kind of broad and generic, but I would suggest sort of thinking in those terms, so that you're not just suddenly jumping to, oh, I really need to sort of sharpen the pencil or go down the rabbit hole on this one thing. There's like a lot that affects the overall environmental efficiency of what you're designing, right?
That's true, but it's very helpful. And what's one common misconception about using technology in architecture, in sustainable architecture, that you wish more people understood?
I think it is how you scale that. I think, a lot of us have our preferred digital ways of working. And one thing that I see time and again, which is a misconception on the part of engineers and architects who have trained to be engineers and architects, is if they have a tool or a workflow that's digital that works for them, that the entire world should adopt it. And I think there's a misconception in the way that technology is scaled in our industry, that it doesn't really matter if it worked for you. The way that successful technological solutions are developed and scaled is someone starts with a blank sheet of paper talks to a lot of people and says, what are your needs? What are your problems? And brings them along on the ride of designing and developing it, right? And so I think that if there's anybody out there that has that really cool tool that you just wish everybody in your organization or all of your peers or colleagues or fellow students were using, just kind of understand that it's better to use that as a use case for storytelling than it is to just become a product manager overnight and try to scale that up into the next big tech startup or something like that, right? It's you don't start with the well-formed thing that you sell. You start with the people you want to sell something to and figure out their problems, and the solution's going to look very different if you go that way.
Can you recommend a few tools or technologies that you feel like are kind of underrated?
Kind of underrated. Well, I think I like Autodesk Forma. I generally like the space that Speckle is in, which is an open source data migration platform. And I think that the reason I like that is because as designers, if you're going to do sustainability study, embodied carbon study, biodiversity study, you're probably going to inevitably use different tools, right? It's sort of like all the apps on your phone. We're moving in a direction that there's these little niche things that do this one thing really well. And so having a way to tie all of these different aspects of analysis together so you can get that big picture view, I think is really important. So things like Speckle, and also I think in terms of BIM, which is, I think, it's something that has been a cross to bear for a lot of small organizations and firms, in the sense that we were promised that BIM would make our lives easier, but I think we put more hours into design because we have to design in BIM. There are generative AI tools that are out there now, like Schema is one that I'm talking to right now, which is a startup that's using generative AI to get the BIM models up and running much faster and earlier in a concept stage, and where they can be plugged into these kinds of sustainability analysis. So I would say if you're, particularly in a space where BIM has been a big cost to your projects, look at what generative AI is doing in terms of allowing you to document and analyze earlier and faster.
Yeah, it's really cool. I think I'll put like a list in the description with all your non-sponsored recommendations. And out of all the projects you've worked on, is there one that really stands out as your favorite?
I worked on Fulton Center, which is a major transit terminal in New York. That one got built, and for anybody who's had a passion project for a long time that you've put a lot of blood, sweat, and tears in, then you saw it built, there's no feeling in the world, in your professional world, that compares to that. But I have to say, I think the sort of the defining project for me was that airport with Foster and Partners and Fernando Romero, which just had so many challenges and was so fast. And we just had the right team of innovators and out of the box thinkers. And we didn't let the apparent impossibility of the project get us down. And I think that it's been inspiration for me that we can, in fact, do things differently. It's oftentimes when the project conditions necessitate that we do things differently that we're best at doing things differently. But it is something that I carry with me, that just because things have been done one way for a long time doesn't mean you can't do it a different way.
That's so true. That's actually a wonderful ending, Zak. Thank you so much. If our listeners want to follow your work and see a bit more of what you do, where can they find you?
You can go to my personal website, zakkostura.com. You can also find me on LinkedIn if you like, or Instagram or Blue Sky. Feel free to reach out. I love talking to people who are interested and passionate about this.
That's really cool. Thank you very much, Zak.
All right. Thank you, Ladina. It's been great.
A huge thank you for listening. Make sure you subscribe to the show wherever you listen to the podcast to support me and so you don't miss an episode. And while you're there, I'd also be so grateful if you could rate and review us. If you have any guest suggestions or any feedback, you can find me on the socials at @LadinaSchipf. Thanks.